Hello, class. This is Mr. Hart, and this podcast I want to start looking at the weather chapter in our textbook. Okay, so up to this point, we've talked a lot about the atmosphere. We want to start getting into weather, which is really, if you think about more of the local side of the atmosphere, right? So when you go outside and you look in the sky, and you see that it's a cloudy day, right? That's the weather for your city, right? But it's not going to necessarily be the same weather somewhere else, right? Whereas the atmosphere is pretty consistent for everybody. So weather is a kind of a very local term, right? It's something that pertains to a specific place, right? So the weather is the state of the atmosphere at a certain place and time, right? So the weather here is going to be different than the weather in New York, for example, or the weather here is going to be different than the weather in Australia. Okay, but also the weather here is also going to be different in 2 hours or in 4 hours or in 6 hours. Okay, so we want to look at our atmosphere at a specific place and a specific time. Okay, and so there's lots of things we associate with weather. If you just watch a weather report or listen to one or look one up online, you can find a lot of terms that they use. Okay, here are some of the more common ones. Obviously, air temperature, right? The temperature outside is a big one. Air pressure, if there's like fog or some other thing like that. If there's humidity, right? Humidity, the amount of water in the air. If there's cloud cover, if there's precipitation like rain or snow, what the wind speed is and the direction. Okay, so hopefully these terms are familiar to you either from previous science classes or you just kind of know them from your own experience. Okay, just watching weather reports and you know going outside. Hopefully you are familiar with some of these terms. Okay, but we want to start getting deeper into what weather is and what causes it. Okay, and so we want to think about what is the source of every one of these things, right? What causes different air temperatures? What causes different air pressures? What causes fog? What causes humidity? And so on. Okay. And if you look at it and you really think about it, it turns out that the sun is the source of all weather. Okay. Now that might seem kind of strange. Okay. The sun is the source of all weather phenomenon, right? Does that include even rain? Right? It seems kind of counterintuitive that rain would be caused by the sun. But let's think about this, okay? If we say rain is caused by the sun, okay? So here's a rain cloud. Sorry, I'm not the best drawer, but here's a rain cloud. Here's the rain falling down, okay? That rain came from this cloud, right? That cloud probably was blown over from a ocean, right? It probably formed above an ocean, okay, and then blew over land, or it formed above a lake or a sea, okay, and it blew over the land and started raining, okay. Well, how did that cloud form above the ocean? Well, it evaporated the air particles until they came up and formed a cloud, okay. So that cloud is a just evaporated water particles, right? Well, why did those water particles evaporate? Well, it's because the sun heated them up in the first place. The sun rays came down, started heating up the ocean. Okay, that ocean started evaporating those water particles. Those water particles formed into the cloud. That cloud blew over into the land. That cloud then condensed and started forming rain. That rain fell on us, and now we have that weather effect. Okay, so even rain comes from some type, or it comes from the sun in some way, right? No matter what the weather phenomenon is, if you really think about it, okay, it comes from the sun at some point. Okay? So, if you are doing this for participation, I want you to do a little activity really quick. I want you to look at these different weather phenomenons, and I want you to explain to me how the sun is the source of those phenomenon. Okay, how is air temperature affected by the sun? Okay, that's kind of an easy one, right? The air just absorbs the sun rays and turns it into heat. Okay, but I want you to tell me, like, where does air pressure? Why is that caused by the sun? How is humidity, the amount of water in the air, caused by the sun? How do clouds form? How are they caused by the sun? How does rain come from the sun? We kind of just did that one, okay? But kind of re-explain it. How does the wind come from the sun? Okay, so if you're making this up for participation, let's do this activity. I want you to show me how these different phenomenon come from the sun. Okay? All right. So let's move on. Now we're going to look at the different parts of weather. Okay? We're just going to go into a little bit of detail about each one of these phenomenon, some of the common ones that we know. Okay? We're going to start with humidity. Okay? So if you want to be clear about the definition, humidity is the amount of water vapor in the air in a particular spot. Okay? And so it's just, again, most people say how much moisture is in the air. Okay? So Utah's usually pretty dry compared to like Texas or Florida or California because they're a lot more humid. Right? They have a lot more water in the air. Okay, so humidity is just a measure of how much water there is in the air. Okay, and so we kind of give it a percentage. So we say like it's 60% humidity or it's 80% humidity. Right? We give it a percentage. Okay, that number is what we call the relative humidity. Okay, the relative humidity. And that what that means is it's the amount of water in the air compared to how much it could hold. Okay, so if I'm at 60% 60% humidity, then that means the air is holding 60% of the water that it could hold. Okay, and so it's not like if it's 100% humidity, that means we're swimming in water. Okay, 100% humidity just means the air is holding 100% of the water that's capable of holding. It doesn't mean that the air is 100% water. Okay, so hopefully that makes sense. Okay, if not, look up relative humidity. Okay, and kind of get a better idea. But just again, it doesn't mean that's the amount of water in the air is or 60% water. It just means that air is holding 60% of what it can hold. Okay, so this is kind of a really long definition of relative humidity, but I'll go ahead and read it. We usually use the term humidity to mean relative humidity, the percentage of water vapor a certain volume of air is holding relative to the maximum amount it can contain. If the humidity today is 80%, it means that the air contains 80% of the total amount of water it can hold at that temperature. What will happen if the humidity increases to more than 100%? The excess water condenses and forms precipitation. Okay, so again, hopefully that kind of gives you an idea. It's the amount of water that it can hold, or it's the amount of water compared to the amount that it can hold total. Okay? All right. So the next thing we want to cover is what we call dew point. Okay, and so dew point is the temperature at which the air is completely saturated with water, or in other words, when humidity reaches 100%. Okay, 100% relative humidity. Okay, and so this graph over here kind of shows what we're looking at. So this line is what we call the dew point line. Okay, or in other words, it's what temperature. Okay, this degrees down here is the temperature. So like at 40 degrees Celsius, this air can hold 50 grams of water per kilogram of air. Okay, 50 grams of water per kilogram of air. So at 40 degrees Celsius, it can hold 50 grams of water per kilogram of air. Okay, so this is the dew point. So for example, let's say I'm sitting at right here. It's 50 degrees outside, okay, which is ridiculously hot. But let's say it's 50 degrees outside, and I'm holding 60 grams of water per kilogram of air. Okay, so if it starts to cool down, okay, I'm going to start moving along this line. Okay, but when I cross this point, right, the dew point, I cross this point right here, that's when I reach 100% humidity. Okay, so after that, all the water that the air can no longer hold, okay, is going to turn into dew, right? Dew on grass, dew on windshields, okay? Just condensing water on surfaces, okay? So once it reaches that dew point, to the temperature where it can no longer hold that much water, it's going to condense that water and it's going to form into some type of precipitation, usually on grass, on the windshields, right? That condensed water. Okay, sometimes it can even rain, depending. Okay, but that is the idea, right? So once it cools down enough, it goes past that dew point. That leftover water turns into um, rain and dew and other forms of precipitation. Okay, so it's very important to know the dew point because usually at night we do cross the dew point line, and that's why you usually find dew on your grass in the morning because it cooled down past the dew point. Okay. All right. The next thing we want to cover is clouds. Okay. So there's lots of different types of clouds that you probably learned in a previous science class. Okay. Kind of different types of classifications. There's cirro clouds, there's stratus clouds, alto clouds, cumulus clouds, nimbo clouds. Okay. And so there's lots of different groupings, there's lots of different types, there's mixing and combos. But this is how I like to think about it. Okay. It's what I call the clouds grid. Okay. Or the cloud grid. Okay. So the first three groupings, okay, are by height. Okay. So a cirrus cloud, for example, is really high up in the atmosphere. An alto cloud is in the middle of the atmosphere. And if we don't give it a prefix, then that means it's kind of near the lower atmosphere. Okay, so that's the y-axis of our grid. Okay, then along this way we have kind of what we call the different types of clouds. So a cumulus cloud is a really like fluffy cloud. Okay, kind of what you imagine when you think of a cloud, kind of the cartoonish type cotton ball looking clouds. Okay, so we call those cumulus clouds. Then there's stratus clouds, which are kind of the wavy type clouds, very thin, wispy. And then there's the nimbus clouds, which are very large clouds that kind of extend through the entire atmosphere. Okay, so this is kind of our grid. This is how we classify it. First, we classify it by height, then we classify it by type. Okay, so let's imagine we have a cloud right here. It's in the upper atmosphere, and it's kind of that cotton ball type shape. Okay, this would be called a cirro cumulus. Okay, cirro meaning it's really high up, and cumulus meaning it's the cotton ball type cloud. Okay, so if it was a little bit lower in the atmosphere, we call it, or it'd still be kind of the, sorry, I'm a bad drawer, but it'd still be kind of the fluffy looking cloud, right? But still, it's a little bit lower in the atmosphere, so we'd call this an alto cumulus. Okay, so again, we start the prefix with the height, and then we put the type. Okay. And then if it was just in the lower atmosphere, we don't give it a prefix, but still got that cotton ball shape, we would just call this a cumulus. Okay. So, again, these are all kind of the same type of clouds, right? The cotton ball, make, cloud pictures out of type clouds, right? But we classify them by their height. Okay. So we put the height first, and then we give the type. Okay. So then if we have the wispy, thin, wavy-like clouds, okay, but then in the upper atmosphere, these would be called cirrostratus, okay, cirrostratus, okay. If they were in the low or in the middle, they'd be called altostratus, and if they were down here, they would be called just stratus. Okay, so I won't take the right time to write them out, but hopefully that makes sense. Okay, so you give the height, then you give the type. Okay. That's kind of the main grid. And then nimbus clouds are kind of in their own group because they extend through most of the atmosphere. They're really tall. So we don't really give them a height. Okay, but we have two types. So there's kind of the towering, spiral looking clouds that are really tall, okay, which we call cumulo because they kind of look like the cotton ball type clouds. Cumulonimbus. Okay. So nimbus kind of meaning these giant clouds that kind of extend through the whole atmosphere. And then we have kind of the darker storm clouds, okay, which usually cause rain and lightning. Okay. These we call nimbo. I'm sorry for the bad handwriting. Nimbostratus. Okay. So there you go. So hopefully you have this grid written down. This is how I want you to remember the different types of clouds. So this is the main grid with the different heights and the different types, and then there's the two kind of special nimbus clouds. Okay, and so hopefully that makes sense how we classify them in this kind of grid shape. Okay, but if you have that written down, and now if you look back at this picture we had before, hopefully that makes more sense. So we click here. Okay, so we have, upper atmosphere clouds, the cirrostratus, which is really high up, kind of wavy looking material. Then we have the cirrocumulus, which is more of the fluffy cloud type. And then we have kind of a special type, which we just call cirrus, okay, which is a very special group, but I'm not going to worry about that. We're just going to look at the main ones. Okay, then we have the altostratus, right, in the middle atmosphere, but kind of the wavy type. We have the altocumulus, which is kind of the cotton ball type in the middle atmosphere. Then we have the cumulus, right, in the lower atmosphere, so it doesn't have a prefix. It's more of the cotton ball type. Then we have the stratus, okay, which is the low atmosphere wavy type, okay. And then we kind of have this middle ground, which we call stratocumulus. Again, I'm not going to worry about these. So don't worry about this one, and don't worry about this ones. These are kind of like cross breeds between the other clouds, excuse me. Okay, then we have the nimbostratus, right? The storm clouds, the dark rain cloud type, the large rain clouds, storm clouds. Then we have the cumulonimbus, which is kind of these large spiral extending through the whole atmosphere type clouds. Okay. So hopefully this picture makes a little more sense and gives you a little bit more visualization of what we're talking about. Okay. And hopefully you can kind of see how it relates to this grid we just drew. Okay. All right. So really quickly, if we look at some clouds, hopefully you can kind of pick them out. So this would be kind of a stratus, okay, maybe a cumulus, but probably a stratus in the upper atmosphere. So maybe like an altostratus or a cirrostratus. Okay. These are, cumulus clouds, nice cotton balls, probably also in the middle atmosphere. So maybe an altocumulus or a cirrocumulus. Okay. These clouds are also cumulus clouds, but they're very low, so these are probably just cumulus. Okay, this picture kind of has two different levels. You can kind of see it here, so this is really cool. These are both cumulus clouds, but these might be cumulus and altocumulus, or maybe altocumulus and cirrocumulus. Okay, so hopefully you're starting to get the idea. At first, you classify by the height and then by the type. Okay, and you can name the different clouds. All right. The last thing we want to talk about is fog, which is kind of when you can think of it like when a cloud settles on the ground. It's not exactly that phenomenon, but it's a pretty good idea. And so hopefully you realize fog is bad for driving conditions and things like that. It kind of blocks your line of vision a lot. And if you want to learn more about fog and the science of fog, I highly recommend this video. So just visit that website. It does a really good job explaining what fog is and kind of how and why we study it. Okay, but that is all we want to cover for this podcast. Hopefully, I know there was a lot to absorb in, but hopefully that makes sense. Hopefully you're familiar with a lot of these terms about weather. And let me know if you have any questions, and thank you for watching.